Hello everyone, my name is Loi Kim Chu, and today we're going to solve a math problem. The problem states that we have three students, A, B, and C, and they're passing a ball to each other. We want to find the number of variations that can happen if we start from A. We pass the ball 11 times and it ends with A. So we have three players, A, B, and C, and they're passing a ball to each other. So the sequences of passing of the ball can be represented as a sequence of players, where, for example, in this case, A passes to B like this, and then B passes to C like this, and then they pass the ball 11 times, and then it has to end back up at A. We can represent the decisions that the players have to make at every pass as a tree. So first we start at A, and then A can pass either to B or to C. So A can pass to B or to C. If the ball is passed to B, B can decide to pass to A or to C, and C can pass it to A or to B. And I'll draw another layer to C. A can pass to C, can pass to A or to B, pass to B or to C, A or to C. Okay. First of all, we want to make the connection that the depth of the tree is equals to the number of passes that has happened. So, for example, I will represent n as the number of passes that has happened. This here would be n is equals to 1. So after the first pass, this here would be n is equals to 2, and this here would be n is equals to 3. Another connection that we want to make is that the number of players at this node, for example, the number of A at depth n, that's going to be equals to the number of variations where we start at A and we pass the ball n times and then it ends back at A. So to make things easier to communicate, we'll define a few variables. So first we let A at n be number, this is incorrect grammar, but it's short and concise. Let A n be the number, but be number of A at n, and we let B of n be number of not A at n. Okay, so we can plug some numbers in. So for example, this over here would be A1, and A1 is the number of A at depth 1, so that's going to be 0. B1, however, is 2. So we have B and C, which isn't A. A2 will be equals to 2, because there are two A's here. B2 will be 2. This A3 will be also 2, and B of 3 will be the rest, which is 1, 2, 3, 4, 5, 6, 6. Okay. There, looking at this, we can find a few connections that we can make. So, for example, if you add A at n plus b of n. So for example, a of 3 plus b of 3, you're going to end up with a power of 2. So for example, 2 plus 6 is 2 plus 6, that's going to be 8, which is 2 to the power of 3, which is the depth of the tree. So we can more generally represent the relation as a n plus b n is equals to 2 to the n. This makes sense because, for example, we let a n be the number of a at n and b n be the number of not a at n. So if we have a something plus with a not of something, you'll get the total number of something that there is. For example, you have a set, you have a subset. This here would be the something, this here would be the not something. And if you add them together, you'll get the whole thing. Okay. Another connection we want to make is that this number and this number is equal. And hence, we can represent it as a n is equals to b n minus 1. Because if the ball gets passed to A, it can only come from a player that isn't A. So that's why we have this relation. This here means that a n minus 1 plus b n minus 1 is equals to 2 to the n minus 1. We can rearrange it. I'll get rid of the 3 for now. And now we can plug this in here. And so we have a n is equals to 2 to the n minus 1 minus a n minus 1. This here is a recurrent relation, and every recurrence relation needs an initial condition. Our initial condition is that after the first pass, there are no variations where it ends up at A. So that's equals to 0. The question asks us to find the number of A at 11 passes. So basically we're trying to find A11. So we can actually rephrase the entire problem as find A11. Okay, so A11 would be 2, so n would be 11, so n minus 1 would be 10. 2 to the 10 minus A10. A10 is equals to 2 to the 9 minus A9. And we can then plug this in here, and we can see that A11 is equals to 2 to the 10 minus 2 to the 9 plus A9. Okay. The pattern is not clear yet, so we'll do another iteration. A9 is equals to 2 to the 8 minus A8. Therefore, A11 is equals to 2 to the 10 minus 2 to the 9 plus 2 to the A and minus A8. Now the pattern is starting to show, but to be even more certain, let's just do let's just plug A8 in here. So A8 would be A to the 7 minus A7, and that means A11 is equals to 2 to the 10 minus 2 to the minus 2 to the 7 plus A7. So we can see that at every odd number, there's a negative sign. At every even number, there's a positive sign. And this will go on until we reach our initial condition A1. So I'll erase this. So this means that A11 is equal to 2 to the 10 minus 2 to the 9 plus so on until A1. Let's just write A2 for now. A2 would be 2 to the power of 1 minus A1, and A1 is 0, so it's just plus 0. Okay. I don't like the alternating sign, so what we can recognize is that negative 1 to the power of an odd number, so this is an odd number, would be equals to negative 1. Negative 1 to the power of even number is 1. So we can actually take the negative sign inside, so we would get negative 2 to the power of 10 plus negative 2 to the power of 9 plus and so on. But we can see that this is starting to look more and more like a geometric sequence. So I'll just add another negative 2 to the power of 0, but we'll also have to minus it by negative 2 to the power of 0. And if you remember the formula for the geometric sequence, we know that x to the power of n plus x to the power of n minus 1 plus x to the power of n minus 2 plus so on plus x plus 1, that would be equals to x to the power of n plus 1 minus 1 over x minus 1. Okay, so our x is nothing but negative 2. Our n is 10, so 10 plus 1 would be 11, minus 1 over x, which is negative 2 minus 1. We can factor the minus sign out, and you'll get this. We can compute this if you know that 2 to the power of 8 is 256. If you know a bit of computer science, you know that this, like in a byte, we can store 256 values. So 2 to the 8 would be 256. 2 to the third would be 8. And you can take 8 times 3, which is 2 to the 11th, and that would be 2048. Okay, 2048 plus 1 would be 20. Oops. Okay, I forgot the minus 1 from right here. 49 over 3, but that's also a minus 1 there. And this thing, this calculation would be equals to 682, which will be our final answer.